So just for the benefit of the video, what I asked students to do was to convert these two equations from power form into log form. So you should have got something like this. X equals a to the power of p would convert to p equals log base a of x. Yep. And if I convert the y equation, I would get q equals log base a of y. All right, good so far? Okay, so what would happen if I took xy? Well, xy would be a to the power of p times a to the power of q, and I'm hoping you remember your log laws, that would mean that xy is equal to a to the power of p plus q.
Oh, right.
Right?
It looks so much scarier when you put letters in it.
I know, right? But we just need to remember, keep reminding ourselves of the fact that letters, well, variables is the more appropriate word to use, are just stand-ins for numbers. So just keep on reminding yourself of that. What I want you to do now is I want you to look at this bottom expression here, and I'll give you a moment to convert that into logarithmic form. Okay, let's see how you go. It would mean that we have, p plus q, that's just a number, is equal to log base a of xy. Now, this is the special thing. Ready? What does p equal? Log base ax. What does q equal? Yeah, it's not too surprising when you think about it, really, that given that exponents add together when you multiply them, that there's this relationship here that you've got xy can be split into log ax and log ay. You know, just like the exponents split when there's multiplication. It's a similar, they're all connected effectively. So that's rule number one, that log base ax plus log base ay is equal to log base axy. Okay, so here's an example problem for you. Just going to do simple ones just to sort of illustrate it. Log 5 plus log 2, right? Log 5 plus log 2. Normally, you would reach for your calculator and you would say log 5 on your calculator plus log 2 on your calculator, and then you'd get a result from it. But this question could very easily be asked on a non-calculator section, because I can make that equal to log 5 times 2, which is log 10, and the log of 10 is 1. Done. And literally, I mean, feel free to confirm this on your calculator if you want to. If you go log 5 plus log 2 on your calculator, you will get 1 as the result, or the universe explodes. One of those two things. So I'll hold on while you do it. It wouldn't be a maths SL lesson if there weren't irrelevant questions. Yes, Ansel. But it's normally Jeremy asking it, to be fair.
But it's not about logs.
Yeah.
How did all of the cultures came to accept using 10 as the base? Like
They didn't. They absolutely did not. The Babylonians. So for the video, Ansel asked, why did all the cultures come to use base 10 as their system of numbers? But I think actually what he was asking was, why did eventually we all settle on a base 10? Yeah. Easy answer to that. As always, unfortunately, it comes down to money, trade. In the early number systems, we had Babylonian system of counting, which was base 16. No, base 12, sorry. We know how base 12 works?
That's why 60 is.
Because you can count to 12 on one hand. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can count to 12 on one hand using the segments of your fingers and your thumb as a counting tool. You can then count to 60 on two hands because you've got 4 fingers and the thumb. You've got 5 digits on one hand. So each of them represents 12. So you can go 5 12s are 60. And that's why there are 60 seconds in a minute, 60 minutes in an hour, and why there's 360 degrees in a circle, because it's all based on 60. But at some stage, the introduction of zero occurred. At some stage, trading between countries, not just trading within a country, but trading between countries became important. And the numeral system called Hindu-Arabic numeral system, which is a blend of Hindu symbols and Arabic symbols, became the default for trade. And as trade grew, it became the most widely accepted use of numbers, base 10. And that is our digression for today. You know what? I do roll my eyes, but isn't this kind of what IB is about as well? Sort of asking those curious questions. Jeremy, and for the record, for the video, Jeremy just made me sad. Okay, so let's do the same thing with x divided by y. See if you can fill out the right-hand side of that equation there. I'll just give you 30 seconds to just get ahead of me. We're substituting in, then we're using our index laws. So using the same stuff as up here, as in these, what x and y equals up here, use that to find an expression here using a and p and q. So a, q over a, q. Yeah, and then use your index laws. And again, let's be really precise with our language. So it's a to the p, or a to the power of p, a to the q. When you say ap, it means a times p, right? So we're going to be really precise with our language, because precision of language means precision of thought, and precision of thought means we're more likely to follow through with our understanding of stuff. I know it probably sounds super pedantic, but it's kind of important. Well, it's not, Jeremy, because pedantry would imply an unnecessary attention to detail, yeah. And I'm saying it's not unnecessary. Yes. So it's not pedantic. So a to the power of p over a to the power of q. And then the law we've got there then is x divided by y is equal to a to the power of p minus q.
Oh, of course, yeah. So I was like, if you put the logs over the logs, just cancel, and you'll prove that x over y is equal to x over y. So that's not helping.
No. Okay, so like we did last time, express this equation in log form instead of power form. Just keep that x over y together.
So much right now. For the record, Ansel is showing blatant disregard for the pain of his farewell. I couldn't tell.
But it's just another day ending in Y, really.
I couldn't tell. Rice, what is wrong with you? No. You can't wait. I can't wait either. Anything but rice. Anything but rice.
I'm gonna establish a product called I Can't Believe It's Not Rice, just so I can eat that instead of rice.
Just stockpile it for next year.
Yep.
We'll just have it on the weekend.
Okay. So hopefully you got this. I just want to get it in the same order as I did on the other one. P minus Q is equal to log base A. I'm just going to put brackets around it so it kind of keeps it together, X over Y. Cool. We know what P is, we know what Q is, and so we can get our second law. So log base A X minus log base A Y is equal to log base A X over Y. Let's do a similar exam. I'll put that in blue. You right? That sounded like a brain explosion. What's tonight? What are you doing? What are you doing?
Piano and poetry. Not me speaking though. Oh, sorry, I got your hopes up.
I did. What are you doing?
He's a rock star.
Oh yeah? Which one?
California Ballads. He's a rock star.
Okay, so here's a really simple example again. Let me just do an... No, this...
Are you still think filling in the name?
There used to be an Irish pub band in Hobart.
Yeah.
And it was called the Dead Kilkennys. So log 20 minus log 2 is equal to, again, really easy, right? 20 divided by 2, which is equal to log 10, which is equal to 1. So again, not as hard as it looks. It's just as long as you remember that relationship. There is a power of a power rule as well. Yeah. Yeah. So for the record, I'm just going to, the video won't show this, but I'm just going to go to the textbook. And where is it?
Richard, what? This is why Mac introduced different desktops, so you could avoid this. Yeah, but then you have like 9 desktops. Yes, it's better than all. You have to search them on desktop because.
Hang on, I'm just trying to figure out whether I care or not, and I just realised I don't. So. So I wasn't going to go through this properly, but I'll add it to the notes later. So I'm just verbalizing it for the video right now, and that is that you do have one more relationship that's an important one, and that is if you take x to the power of n, then that would be a to the power of p to the power of n, and that's what answer you're talking about, that same relationship there of you would then use the power of a power rule to get a to the power of pn, and then when you rearrange it, you get that log base a x to the power of n equals pn, and then you end up with that relationship as well. So log base a x to the power of n is equal to n log base a to the power of x. So I'll write that rule down, but I'll go through it. I'll put a bit more work to it later. Just for the video, I just want to switch back. Sorry. So one more rule, which I'll actually fill in with some detail for the PDF, but it won't be in the video, and that is that log base a x to the power of n is equal to n log base a x. I'll explain what, well, I'll put it into the PDF notes, but this is one other rule. So an example of that, and I don't know, really simple one. Log base 2 of 64 is equal to log base 2. We've got 2, 4, 8, 16, 32, 64 is 2 to the power of 6. So that's equal to 6 log base 2, 2. And log base 2 of 2 is 1. So that just equals 6.
Why is it 226?
That's a base 2 and 2 to the power of 6. There we go. Is that better?
So you're telling me you don't want.
Is that making sense to everybody? Okay. Well, I'll stop. So they're the 3 rules. Some simple examples to go with them. I'll stop the video now and go on to showing you or telling you where in the textbook to find some work to do.